Diethyl ether. Diethyl ether is a molecule made of these parts: 4 carbon atoms, 10 hydrogen atoms, and 1 oxygen atom put together like this. A more streamlined way of depicting the molecule is with a skeletal structure. In a skeletal structure, the carbons are replaced by the kinks or the end of a line, and the hydrogens on them are implied. Diethyl ether doesn't seem to have a significant source in nature on Earth. One of the reasons it might be hard to detect is because it seems to break down quickly. The diethyl ether that's been released into the environment quickly evaporates, enters the atmosphere, and is destroyed there within 2 to 6 days on average. So there doesn't seem to be a significant source of diethyl ether on Earth, naturally. But humans make a bunch of diethyl ether. They make it industrially as a solvent, and it's used especially to do the reactions that make cellulose acetate, which is a type of plastic or bioplastic. The plastic can be used to make cutlery like you see here, or also some types of glasses, frames. Diethyl ether is also used as a starter fluid or a starting fluid in cars to help turn your car engine on, and that's especially important for cars that need to be turned on in the severe cold. As we'll see, one of the most significant things about diethyl ether is how flammable it is. It will burn even at very, very low temperatures, and so it's a reliable way to get your car engine to turn on when you introduce a spark to the starting fluid that contains diethyl ether. Historically, it was one of the first widely adopted anesthetics used for surgeries, and it completely changed how surgeries were done in the West. People erected monuments to diethyl ether. Prior to adopting diethyl ether, many surgery wards were filled with the screams of patients who were having the surgeries done on them. So it was a very early anesthetic, but its flammability made it a dangerous anesthetic to use, because during surgeries, even large amounts of friction would light the room on fire. The ether would evaporate quickly from the mask that they used to apply it to the patient, and so it would be in the air, and a significant amount enough of heat would just light it all on fire, and the surgery rooms would burn down. So nowadays in most countries, they have replaced diethyl ether with other less flammable but equally safe or more safe anesthetics, although in some developing countries they still debate using diethyl ether as an anesthetic sometimes. Safety with diethyl ether. You can summarize the safety considerations for a molecule conveniently in these fire diamonds or safety squares. The blue square on the left represents the danger of a molecule to your health. It's on a scale from 0 to 4, where 0 represents no health hazard and 4 represents a quick death on exposure to the molecule. Diethyl ether is a 2. It will cause eye irritation if the vapor of it gets into your eye, and so when you work with it, you want to make sure you wear goggles. It can cause skin irritation, and that includes drying and cracking of your skin. So when you work with it, you want to make sure you wear gloves and a lab coat. When you inhale the vapors of it, it can lead to headache, fatigue, nausea, vomiting, stupor, and even a coma. It can affect your central nervous system, and it can also cause a condition called pneumonitis, which can be fatal. An interesting measurement to demonstrate the toxicity of a molecule is called the LD50. In any population, some people are more frail and other people are more robust. So the same dosage won't kill everybody. A useful measure then is the dose that kills half of everybody. That's called the LD50. This stands for the lethal dose for 50% of the population. It's the amount that if everybody ingested it, half of everybody would die. It's usually measured in rats, and so it's an approximation for what it would be for humans. But in rats, when given orally, diethyl ether killed half of the rats it was given to when it was given at 1,215 milligrams per kilogram of body weight. Diethyl ether is extremely flammable. The red box at the top discusses a molecule's flammability, and it's also on a scale from 0 to 4, where 0 means a molecule will not burn, and 4 is a flammable gas at room temperature. You can see here, Diethyl ether has the highest rating for flammability that's possible. It is a flammable gas at room temperature. There are two numbers that helped us to communicate exactly how flammable something is. The first is the flash point. This is how hot a molecule needs to be for a spark to light it on fire. If a compound is colder than this, a spark can fall on it and the spark will just go out. But if a compound is warmer than this, if a spark falls on it, it will burst into flames. So that's what's called the flash point. And you can see that's extremely cold for diethyl ether. It's negative 45 degrees Celsius or negative 49 degrees Fahrenheit. And you can see why diethyl ether is used as a starting fluid, especially in cars that need to turn on at very cold temperatures, because this will still burn. This will still respond to a spark at very cold temperatures. Another important number to explain the flammability of something is called the autoignition temperature. This is how hot you would need to get something for it to just burst into flames, even if it's not exposed to a spark, for it to just spontaneously burst into flames. And for diethyl ether, that's 160 degrees Celsius or 320 degrees Fahrenheit. It's not especially hot. You cook, for example, a frozen pizza in your oven at temperatures higher than this, and hot plates can certainly get that high. So you want to be careful when you're working with diethyl ether that you keep it away from heat sources and from flames and sparks. The yellow box or the yellow diamond at the right of this, the fire diamond, these safety squares, represents the instability or reactivity of a molecule. It's also on a scale from 0 to 4, where 0 tells you a molecule will not explode, and 4 tells you that the molecule will explode at room temperature if disturbed. Diethyl ether itself is mostly just flammable, but when it's exposed to air and light, it can form explosive peroxides. So the 1 rating for instability or reactivity really has to do with how diethyl ether is being stored. You don't want it to be exposed to air and light, then it can form explosive peroxides. The empty white diamond at the bottom tells you that there are no special considerations for diethyl ether outside of the health, flammability, and instability considerations. Let's try to visualize diethyl ether. As we saw, diethyl ether, the skeletal structure looks like this, and each of the kinks in those lines, the ends of those lines, represents a carbon with hydrogens on it. But this is a 2-dimensional representation of a 3-dimensional molecule. You can see that each of the carbons in diethyl ether is tetrahedral, and the oxygen in the middle is bent. Notice also that this 3-dimensional representation is color-coded, and it's color-coded to represent the charges on this molecule. The red color is representing a place where negative charge is building up, and you can see that's on this electronegative oxygen atom. The blue color is representing places where electrical charge has moved away from, where electrons have moved away from, and so a positive charge is built up. You can see that's on the things bonded to that oxygen. So the oxygen is pulling electrons to itself, becoming slightly negative, and the atoms bonded to it, these 2 carbons here, are losing electrons and becoming slightly positive, and that's where you're getting that blue color. The green color that's on the side are places where there is no buildup of charge, so they're electrically neutral. These 3-dimensional images that show you the stickiness of a molecule, because that's what electrical charges represent, because opposite charges attract and stick to each other, are called electrostatic potential maps. These bonds are not still and static. They're dancing, vibrating, moving, twisting, turning things. They're dynamic, and at room temperature they vibrate around 10 trillion times. To help you visualize how this molecule looks as it's moving and vibrating and twisting and turning, I'm playing a simulation here. Now this simulation is showing the vibrations happening at a pace where our eyes can make them out. But at room temperature, these vibrations would be happening around 1 trillion times faster than what you're seeing here. Let me speed this up just 10 times. Now let me speed it up 200 times. To visualize this molecule at room temperature, you would need to speed this molecule up more than 25 billion more times. As you zoom out and hundreds of trillions of these molecules merge together, Like pixels on a screen, what our eye sees macroscopically is a clear liquid. Diethyl ether at room temperature at sea level is a clear liquid, as you can see here. That liquid is representing huge populations of diethyl ether molecules. When diethyl ether accumulates in these enormous communities of itself, it takes on a certain personality trait. The personality traits of those communities, of those huge populations of diethyl ether molecules, are called the physical properties of diethyl ether. You can look up physical properties in reliable handbooks, like the CRC handbook on the left here, or the Merck index on the right. One physical property has to do with the phase of a molecule. Is it a solid, a liquid, or a gas? Among other things, that has to do with the temperature of the molecule. Let's think about the temperature, how the molecule looks at different temperatures at sea level. Diethyl ether would be a solid, would turn into a solid, if you cool it below negative 177.3 degrees Fahrenheit at sea level. If you heat it above that, between negative 177.3 and 94.3 degrees Fahrenheit, diethyl ether will be a liquid. Notice that includes room temperature. And above 94.3 degrees Fahrenheit, diethyl ether will turn completely into a gas. As a scientist, you don't just want to think in degrees Fahrenheit, you want to be able to think in degrees Celsius, this metric unit for temperature. And so, to say that again, if diethyl ether gets colder than negative 116.3 degrees Celsius, it will be a solid. In between negative 116.3 degrees Celsius and 34.6 degrees Celsius, which includes room temperature, diethyl ether will be a liquid, and above 34.6 degrees Celsius, diethyl ether will completely turn into a gas. You can use these temperatures, the temperatures at which something freezes or boils, to separate things. If diethyl ether is in a mixture, you could, for example, cool it down so that the diethyl ether freezes and everything else doesn't. And then you can strain the diethyl ether out from the mixture. When you separate things based on their freezing points, it's called crystallization. On the other hand, if diethyl ether is in a mixture, you could heat it up so that the diethyl ether evaporates and nothing else in the mixture does. You can then collect that vapor and have it drain into another container, and you would purify the diethyl ether from the mixture. When you separate things based on their boiling points, that's called distillation. Another physical property that's important is solubility. Solubility is significant because it creates structure within fluids. Let's think about how diethyl ether how soluble diethyl ether is in water at room temperature. Solubility, whether molecules mix or not, really has to do with how many charges are spread out over the molecules. Water has charges on every atom in the molecule. Diethyl ether has charges on the oxygen and 2 of the carbons. Opposite charges attract, so the positive charges of water will want to stick to the negative charges of diethyl ether, and the positive charges of diethyl ether will want to stick to the negative charges of water. So diethyl ether and water will mix a little bit, but notice that there's a lot of parts of diethyl ether that are electrically neutral. Those will not want to stick with water. Water would rather stick to other molecules of water than to stick to that. So there is going to be a limit to how much diethyl ether will mix with water. And specifically, at room temperature, diethyl ether will dissolve, and there will be at a ratio of 60.5 grams. 60.5 grams of diethyl ether will dissolve in 1 liter of water. A final physical property to think about with diethyl ether is its density. Density is significant because it creates structure based on sinking and floating. That's everything that creates layers in our world, everything from the core, mantle, and crust of the rock on the earth to the layers of gases in our atmosphere, and to differences in the density of air that creates winds. And so density creates structure based on sinking and floating. So the diethyl ether, if you mix it with water, the diethyl ether that does not dissolve, will it sink or float on water? That depends on its density. The density of diethyl ether is 0.7134 grams per milliliter. Compare that with the density for water, which is 1 gram per milliliter. Because the density of diethyl ether is less, it will float on top of water in a separate layer of clear liquid. Hopefully this video has given you a better understanding of the molecule diethyl ether.